is this, okay? Column space. So column space of A consists of all the combinations of column. It is denoted by C of A, and it is a subspace of R to the power of M, where M is a number of equations, okay? I'll explain this. Suppose if you have a 3 cross 3 matrix, you'll be having a 3 columns, okay? So, but you can call it as a column space. You for 3 cross 3 matrix, you'll be having a this thing, right? In 3 cross 3 matrix, you'll be having 3 columns. Column space is nothing but combination of all these columns, okay? C1, you consider C1 plus C2, whatever you get after adding, that also comes under column space. Then C1 plus C2, like that, all the possible combinations and all the possible combinations of all the column space, column vectors which is present in that set, just like a vector space, okay? So that is column space. But here the thing is the column space of so column space of A consists of all the columns, combinations of columns. That means both that addition and all. It is denoted by C of A. It is a subspace of R to the power of N, where M is number of equations, okay? And another terminology is null space, okay? Null space of the matrix consists of all the vectors X such that AX is equal to 0. That means that, assume you have a 3 cross 3 matrix, okay? So that is A. You have to find out the solution, all the some of the equations, like 1x1 plus 2x1 plus 3x1 is equal to 0. 4x1 plus 5x1, 5x2 plus 6x3 is equal to 0. 7x1 plus 8x2 plus 9x3 is equal to 0. These three equations, if you represent in the matrix, what you get? 1, 2, 3, 4, 5, 6, 7, 8, 9. Correct? No? That becomes A. Now you have to find out x1, y, x1, x2, x3, right? That's why it is AX here. So that's why it is AX here. When all the solutions possible for this is nothing but a null space. That is the meaning. Null space of the matrix consists of all the vector X such that AX is equal to 0. That means that all the solutions of AX is equal to 0. All the possible values of X is vector null space. So it is denoted by NA, whereas the column space is denoted by C of A. Here the null space is denoted by N of A. And it is a subspace of R to the power of N, where N is number of unknowns. Whereas that one is, it was a subspace of R to the power of N, M was number of equation. Number of equations and number of unknowns should be same. That is what you are expecting. Even number of equations can be more if number of equation unknowns are less, then you can find the solution. But if number of equation is less, number of unknowns are more, then you can't find the solution. That you know, right? So this is related to number of unknowns. That one, column space, was related to number of equations. Okay, yeah. Next is this. Let's solve one problem related to it. Find the column space and null space of the following system. Okay. So here you can observe that this is A, this is X. Okay. Here we'll see why this one it should be 0, no, for null space. We'll see that. So in order to calculate the column space, we need this. So this is the equation. Actually, if you try to analyze that, this is matrix is nothing but a equation only. So first equation was U plus W is equal to 1. Second equation is 5U plus 4W, no, 4V plus 9W is equal to 2. The third equation is, if you do the matrix multiplication, you'll get 2U plus 4V plus 6W is equal to 1, right? So that is a equation actually. So you have 3 columns, right? You have 3 columns. Now we have to find out what is the column space. Okay. So you have the 3 columns, take that 3 columns. What I do is, see, since I told that first column contains all the variable as 1U, 5U, 2U. Second contains 0V, 4V, 4V, like that. If you separate out those variables U, V and W, what you get is this, right? What you get is this. If you separate out all the U, V, W, this will be representation of this. So what is the meaning? So then what you get, these are all the equations, right? I already explained this. When you multiply that given matrix with that, yeah, u, v and w, you'll get these three, right? But now you have to tell me that whether it is a column space. We have to find out that whether it is a column space. Since u, v and w is real, right? All the u, v, w values which satisfies this condition becomes a column space. Okay, all the see, this is a column space. These three vectors are there in the column space, and all the combinations possible for u, v, w, that means 1 0 0 0 1 0 0 0 1. See, I'm given one example here. 1 0 0 you take, that means you'll get 1 5 2 only. It's already there in the column space. So you take 0 1 0, like that. You consider all the possible cases, all the possible combinations which satisfies that previous equation comes under the column space. Okay, yeah. Next one is null space. So just write that, that's all. Write the columns and write that variables that gives the column space. Whereas the null space is, the definition itself says that ax is equal to 0, right? So you have to take that in that question. You have to make all the constant is equal to 0. Ax is equal to c. You have to make all the c is equal to 0. Then only you can calculate the null space of that value of a, right? So I made it all is equal to 0. Then you do the matrix multiplication. What you get? The same thing. The above whatever we have written, the same thing you'll get. But right hand side it will be 0. U 0 and u plus w you'll get 5u, 4v, 9w, like that. You'll get three equations you'll get after doing the matrix multiplication. Now what they want is, what is the meaning of null space? All the possible cases of u, v, w, if you find out, then it becomes the null space. Okay, all the possible cases of u, v, w that satisfies this equation. So how do we solve this? You have done it long back, right? It's very simple. U plus w is equal to 0. I have to find out what is the u, v, w, right? So obviously from the first equation what you got, from the first equation what you got is this, right? U is equal to minus w, right? From the first equation. Whereas from the second equation, you know, second and you substitute for second equation and third equation, substitute 1. That means u is equal to minus w, you substitute for second and third equation. So what is the second equation? 5u plus 4v plus 9w is there. You substitute u is equal to minus w. What you get is 5u becomes minus 5w. The other variable remains as it is. 4v is 4v, 9w is 9w. Only did what I did was u I replaced with w. Then again for the third equation, replace u by w. What you get is minus 2w plus 4v plus 6w. Same as this, right? Only here this is the change. Now if you observe these two equations, what you can see is you had a minus 5w and 9w. What you get is 4w, and another one is 4v. Only two variables are there, v and w. So minus 2w and plus 6, it becomes, oh, again mistake, huh? Yeah, actually it is what, 4w, right? It is 4w actually. Minus 2w plus 6w is 4w. Here it's 4v you write. Then what happens is, then both the equations become same, right? Because it's a 4w. Then same equation, what you get is this 4w is equal to 0. That means 4v is equal to minus 4w. Finally what you get? V is equal to minus w, right? So three conditions you got. Everything in terms of w. U is minus w, v is minus w, w is w, right? So finally what you get? U, v and w. See, you remember this properly. We are going to write from now on, you are going to write all these things. U, v and w, you expressed as in terms of w. So u is minus w, v is minus w, and w is w. You take w out of that, what you get is minus 1 and minus 1. No, minus 1 and 1 times of w, where w is belongs to R. This is called as null space. You consider all the values of w which is in real world. That means any value you take that satisfies that equation. Okay, so that makes it very simple. Okay, solution of the equation, if you try to find out the null space, you'll get a overall picture, all the possible solution and the overall thing you'll get. So you substitute all the values of W which is in the real world. Real world means any value that is real, you substitute, that becomes a solution for that equation. Okay. So since two equations was same, literally it means that there is no three variables, two equations. That's why you got like this. Yeah. Next is this. So what we did previously was we taken the actual equation, right? Matrix they have given. Then you calculated the column space and null space. Column space is simple. Just you write the column separately and with respect to the variables. Whereas the null space is you equate the actual equation to zero. That is how that is the actual definition of a null space. You try to find out what is the solution. See, in general, you should find out. Okay, and don't substitute. You used to substitute W is equal to 1 like that. You can do it, but first you have to find out W general value. You should find out. It's better being an engineering student. Okay. Yeah. So answer was this, right? Final. This is if you write UVW as minus W minus W W minus W. So that gives the actual null space. Okay. So next is this. Next question is determine if 1, 3 and minus 4 is in null A, where matrix A is given. Okay. Matrix A is given and they are giving one more vector. Okay. Matrix A is given, they are giving one more vector. They wanted to find out this vector presents in null A. What is null A? It's a set of vectors. What this set of vectors, what is the common property this set of vector has is when you multiply with this A, you'll get 0. All the vectors which is present in a null A, you multiply with this, you'll get 0. That is a property. Now what they're doing is they're giving some vector 1, 3, minus 4 and they wanted you to find out whether this exists in null A. That is, null A means set of vector. Column A is also set of vector. So you wanted to find out whether this exists in the null A, in that set of vectors. What is a simple thing what you can do is just multiply these two, right? You do the matrix multiplication. What is the expectation? You should get 0. If you get the 0, this exists in the null A. If you don't get the 0, it is not exist in the null A. Okay. So you multiply these two matrix, right? So what happens is, so once you multiply, you know the matrix multiplication, right? Column, row with respect to the column, right? 1 into 3, minus 5 into 3, minus 3 into minus 4. So answer what you got is this. So 3 into 1 is 3, minus 5 into 3 is minus 15, and 3 into minus 4 is what? 12. Like that you get it, you do it. So if you had minus 15 plus 12 plus 3 is 0, 6 minus 6 is 0, 12 minus 8 minus 4 is 0. See, if you are when you are solving, if you are getting this kind of patterns, you know, definitely the answer will be correct most of the time. Yeah. So what we did is we wanted to, you know, calculate whether this exists in the null space. Just we multiplied with the matrix. The expected answer was 0. So that is there, right? So 1, 3, 1, 3 and minus 4 exist in the null A. Okay. Yeah. This is the assignment 2. Anyhow, I'll share that. In this assignment, yeah, I have given described the column space, right? So you have to find out column space and null space for ABC. And in the second question, for which vectors do the system as a solution? So you have to find out whether for what values of B1, B2, B3 solution exist. In these two questions are given. One in the same question only, but last row is changed. 0, 0, 1. In another example, it is 0, 0, 0.